In this lesson, we're going to find missing side lengths using what we know about scale factors, and also look at the relationship between scale factors and perimeter and scale factor and area of two similar figures. Just some vocab. Remember that perimeter is the distance around a figure. So if you add up all the sides of a polygon, you can get the perimeter. And the area is the amount of space occupied by a two-dimensional figure. Scale factor is a number that side lengths can be multiplied by to give the corresponding side lengths. So the scale factor from parallelogram ABCD to WXYZ is 4, because if you multiply 5 times 4, you get 20. If you multiply 4 times 4, you get 16. So we're going to use scale factor to find missing side lengths. So the technique I do is, first, whatever side is missing, I start with that part. So see how the X is right here? That's the part I'm going to start with. Then what I do is I look at a side that I'm already given. So I'm given 3. And I take 3 and I divide it by the corresponding side on the other polygon. So in that case, that's 6. So I do 3 divided by 6. So that gives me a scale factor of 1/2. Okay, so to go from this triangle to this triangle, I'm going to take 1/2. I'm multiplying it by 1/2. So that means I have to take on the side that I know, okay, of the polygon that I know, I take 10 and I multiply it by 1/2. So 1/2 times 10 is 5. So the answer is 5. We're going to do a few more. So I always start with the polygon that I don't know and take one of the sides and divide it by the corresponding side. That gives me the scale factor, and I take this number and multiply it by the scale factor, because 10 corresponds with X. So let's try it again. So I have, this was where I start. So I'm going to take 50 and divide it by 20, and this will give me the scale factor. So 50 divided by 20 is 5/2, and then I'm going to multiply it by 30. So this is going to be 5 times 30 is 150 divided by 2, because I multiply the numerators and I multiply the denominators, and now I can reduce it. 150 divided by 2 is 75 feet. Okay, let's try it again. Find the missing side length. So we're trying to find this. So I'm going to start with this triangle. So I'm going to do 6 divided by 4. That will give me the scale factor. You can do it as a decimal or a fraction. So 6 divided by 4 is 3/2 or 1.5. And I'm going to multiply 1.5 by 5. So I put a 1 underneath it, and this is 15/2. So this is an improper fraction that's reduced. If you want to write it as a decimal, you can do 2 goes into 15 7.5 times. So that's 7.5. Find the missing side length. So this time we have 2 overlapping triangles. So what I'm going to do is I'm going to draw them out separately. So first I have this small one, which is 4 and 6. Then the outside one is Z and 10. So it's much easier if you write them out separately. So now I find the scale factor. So I start at this triangle and do 10 divided by 6. 10 divided by 6 reduces to 5/3, and I multiply that by 4 to get Z. So times 4/1 is 20/3, and this is an improper fraction that's reduced. These two are kind of drawn in a different orientation. So one's rotated, so I'm actually going to draw it like this. So 7.5 is the short side and A is the long side. So you can always draw them out separately. So again, I start with the side that has a variable on it, or the side that I'm trying to figure out. And I do 7.5 divided by 3, which is 2.5. So if I have a decimal, it's okay to have a decimal with my answer. It's kind of a rule of thumb. If your question starts with a decimal, your answer could be a decimal. If it has a fraction, you can answer as a fraction. So 2.5 is a scale factor. So now I'm trying to figure out A, so I'm going to take 2.5 and multiply it by 4. So 2.5, 4 times is 2.5 plus 2.5 is 5. And 5 times 2 is 10, so it's 10 centimeters. If there's a unit, I'm going to write the unit. Okay, again, we have two separate triangles out, so I'm going to split it up. So I have 1.6 and 1.25. I'm trying to find the height of the tree. So look at here how this is actually 4.75 plus 1.25. So this is going to be 6 meters. And I don't know the height of the tree. We'll let that be x. So to figure out the scale factor, I do 6 divided by 1.25, and then I multiply it by 1.6. Since these started out as decimals, I'm going to end as a decimal. So I get 7.68 meters tall. So I did this on my calculator because I had mixing up decimals. Now let's look at the relationship between perimeters and areas of similar figures. So if I take a simple square, the area of this square, it's kind of easy to see, is 4 units. And the perimeter is 2 plus 2 plus 2 plus 2 plus 2. The perimeter is 8 units. So the area is 8 units squared, I should have said squared, and the perimeter is, or 4 units squared, and the perimeter is 8 units. So what happens if we double it? So let's double the side lengths. Can you see how many squares would fit in there? So the area is now 16 units squared, and the perimeter is now 4 plus 4 plus 4 plus 4, 16 units. Let's try it with a smaller figure. And let's triple it. So the area right here is 1 unit squared, and the perimeter is 4. Now let's triple it. So the area is going to be 3 times 3, which is 9. And the perimeter is going to be 12. So can you see what's happening if I write out the first area was 4 and it turned into 16 when I doubled it. The first area was 1 and it turned into 9 when I tripled it. So what's going on with area is you're taking the scale factor, you're multiplying it by the scale factor squared. So you take the original area and multiply it by the scale factor squared. That's for area. For perimeter, you take the perimeter and you multiply it by just the scale factor. Because here, if we tripled it, we went from 4 to 12. We multiplied it by 3. Here, we doubled it and we multiplied the perimeter by 2, which was the scale factor. So area, you multiply by the square factor squared. And perimeter, you just multiply it by the scale factor. Here's a visual proof. So right here, your triangle is now doubled. So now there's 4 triangles. So the area of it is 4. So the area is quadrupled because it was doubled. So it was multiplied by 2 squared because the scale factor was 2. The perimeter has went from 3, 1, 2, 3, 4, 5, 6. The perimeter has went from 3 to 6. The perimeter has been multiplied by the scale factor, which is 2. The two figures are similar. What's the perimeter of ABCD? So 2 plus 2 plus 4 plus 4 is 12. And what's the perimeter of this? Well, 8 plus 8 plus 4 plus 4 is 24. What's the scale factor of the blue to green rectangle? So from going to here, what are we doing? Well, we're going from 4 to 8. So to figure out what we multiply by, we have to divide. 8 divided by 4. So 8 divided by 4 is 2. What's the perimeter? What's the scale factor of the perimeter of the blue triangle to the red to the green? Well, that's times 2 as well. Because remember, you take the original area and you multiply it by the scale factor to get the perimeter. Now let's check out the area. So the area of ABCD is the area of a rectangle. So 2 times 4 is 8. Now, without doing the area of the green, well, I guess I'll do the area of the green first. That's 8 times 4 is 32. So what's the scale factor of the areas? Well, remember, the scale factor was 2, so the scale factor of the areas is 2 squared. So you're multiplying it by 4, which that's how we go from here to here, we're multiplying by 4. The two figures are similar, so let's find the perimeter of the larger rectangle. 6 plus 9 plus 6 plus 9, so that's 15 units, or 30 units. The perimeter of the small one is 3 plus 3, which is 6, plus 2 is 10. So find the scale factor of the larger to the smaller rectangle. So how are we going from here to here? Well, we need to divide 3 by 9, which is 1/3. So that makes sense because this perimeter is 1/3 of this perimeter. So the scale factor of the perimeter to the larger to the smaller is 1/3. Now let's find the areas of these. So 3 by 2 is 6 units squared. So I wrote that in the wrong spot. So this is 6 unit squared. And this bigger one is 54 units squared because 6 times 9 is 54. So to go from the 54 to 1/6, what you're doing, or to 6, is you're taking the scale factor and you're squaring it. So to square it is to multiply it by itself twice, so it's 1/9. The scale factor of the area of the larger to the smaller is 1/9, because 1/3 times 1/3 is 1/9. So just to recap, similar figures have scale factors that are the same as their perimeters. If the scale factor is 2, the relationship between their perimeters is also times 2. Similar figures that have scale factors are different for their areas. So remember, the scale factor for the area is times the scale factor squared.